Yes. So and the recording will be made available.
Uli, can I ask you to, if possible, collect the questions that are asked in the chat in case we're not able to cover everything, so we have it for later.
Yes, that's a good idea. I will do this, Andre. Yes.
Thank you.
Okay, I think we should go ahead. Keivan, I'll hand the mic over to you.
Okay, I suggest we get started, Uli.
Yes, Keivan, could you hear me earlier? Keivan, can you hear me?
Yes, I
Okay.
can. Sorry.
Okay, so yes, please go ahead. We are ready.
Okay, great. Thank you. Hello, everyone. Good afternoon or good morning, depending on where you are. Welcome to this special edition of the Imaging Informatics Community Webinar. I am Keivan Farahani, Program Director for the Cancer Imaging Informatics with the Center for Biomedical Informatics and Information Technology at the National Cancer Institute. Hello?
Keivan, we can hear you well.
Okay, I thought there was a question. And joining me is Ms. Uli Wagner. She's with the Frederick National Laboratory for Cancer Research. She's the hostess of the Imaging Informatics Community Webinar and also project manager for the Imaging Data Commons, the project that we will be hearing about today. And I serve as the NCI lead for the IDC. So the presentation today will be given by Andrei Fedorov, Dr. Andrei Fedorov from Brigham and Women's, and he has with him Denis Bontempi, who will, I believe, present a use case. And so without further ado, I'll turn it to Andrei. Andrei, please go ahead.
Thank you. Thank you, Keivan. Let me share my screen.
And I'd like to mention that we do have a record number of participants, which is great to see.
Excellent. So
thanks, everyone, for joining.
Can you see my screen?
Yes.
Okay. So thank you very much to Uli and Keivan for organizing this webinar and inviting us to present about Imaging Data Commons. And also thanks to everyone who joined. It's great to see so many attendees and many friends on this call as well. So today I want to give you an introduction that follows the release of Imaging Data Commons pilot that happened last month. I will present this. I'll present this together with Denis, and I present this on behalf of the team that composes the Imaging Data Commons Consortium. The consortium was led by Dr. Ron Kikinis. Together with Ron, I'm a co-PI of this project. In addition to the Mass General Brigham, we have Institute for Systems Biology, General Dynamics IT, Pixelmet Publishing, and several other companies and academic institutions that contribute to the development of this resource. I also want to acknowledge the contribution of the stakeholders and our project leads at the Frederick National Lab, Todd Peel, Keivan Farahani, and Uli Wagner, and also the contribution of the advisory boards that provide their feedback and to which we report our progress and coordinate our plans. I want to give from the beginning the acknowledgement of the entire technical team that has been contributing to this development. So here are list all of the people who have been contributing to IDC development. So the outline of this presentation, I want to have a hopefully interactive presentation where I want to tell you about Imaging Data Commons and what it is about, but also interleave the slides with the demonstrations And also, I want to emphasize that everything that I will be sharing with you is available for you to reproduce. We have links to everything that I will be shown in the documentation, and in addition to demonstrating the capabilities of the portal and Imaging Data Commons resource, Dennis Bontempi, who is a researcher working with Hugo Ertz, will talk about development of a use case for specific radiomics study that utilizes the capabilities available in Imaging Data Commons. As the last portion of presentation, I want to discuss what we are working on right now and pose some questions where, if there is feedback from the community, we'll appreciate you letting us know if we are going in the right directions and whether you have concerns. And I hope with the hour-and-a-half overall scheduled for this session, we'll have plenty of time for questions in the end. So Imaging Data Commons is not a standalone resource. I want to start by saying that it has been established as a new component of the NCI Cancer Research Data Commons, or CRDC. And CRDC is one of the resources that has been established for the cancer research community by the Joe Biden Cancer Moonshot effort. The idea is that to establish a virtual cloud-based collaboratory that can be used to identify relevant data sets, identify tools, and without having to install those tools on local resources or download the data, been able to apply the analysis and reproduce the studies, being able to share those results with the community, and also develop the components that can be used not just for cancer imaging research, but also for building other commons in other disease domains. So this is the high-level architecture of the Cancer Research Data Commons. And as you can see here, at the bottom are the data nodes. And these are the domain-specific entities that are supposed to provide the interfaces to explore and interact with the data specific to their domain of expertise. So the Genomic Data Commons node has been established as the first one. It has been around for many years now. Integrated K9 Data Commons and Proteomics Data Commons have been established rather recently, and Imaging Data Commons is the most recent addition to the set of nodes that are included in CRDC. So as you can see, within each of those nodes, you have a repository of data that follows the conventions specific to the domain of the node. The data model is also specific to the node. All of the nodes are expected to provide APIs for the users to interact with the data and provide the node portal that allows the user-level interaction with the data and building of cohorts without having to exercise the APIs. Then Cancer Data Aggregator is this new entity that is not live right now, but the project to develop this component has already been funded, and it's expected to be released in pilot mode sometime next year. So the Cancer Data Aggregator is supposed to provide this unified interface that would allow to query those different types of nodes and build cohorts of data from different domains. In addition to nodes and the Cancer Data Aggregator, there is also this group of entities within CRDC that are called NCI Cloud Resources. And these are the components that are intended for the user to implement the analysis workflows, pool the data, deploy tools, and provide these highly usable and accessible components for performing the computation. So I'm talking about this in order to make sure that there is an understanding that Imaging Data Commons is not something that provides everything, all of the capabilities, including compute and tool repositories to the user, but it's one of the components of a bigger infrastructure of CRDC. Of course, a natural question is, why would we bother to do computation on the cloud first? Of course, there is proliferation of using cloud services and resources right now, but they're not so common in the research domain. And in this slide, some of those problems and solutions that cloud is, can provide to the research community are highlighted. By using the cloud, we do not need to download and re-download data to local resources, and instead have a single centralized location of the data that can be used by multiple researchers. And this has definitely the potential to simplify and enable reproducibility of analysis. The resources on the cloud are highly scalable. You do not need to think in advance how many nodes in your cluster you need to allocate. You can allocate those resources and pay as you go and use only what you need. Of course, security is a big component of the cloud. You will have to put your data outside of your institution potentially, or work with the public data sets. But at the same time, cloud providers have thought about this very diligently, and the centralized security can provide this shield of protection for the users of the cloud. But at the same time, arguably, each solution has its own problems, and cloud computation is not an exception. Definitely, there are concerns that the cloud, the data would need to leave the realm of the institution, and you will not find all of the tools necessarily that you're familiar with on the cloud, and it will require the effort to install them. The cost is definitely one also a significant concern, because when you, of course, if you budget for a local cluster or the laptop that your postdoc will be using, you know how to do this. You know how to put this in your NIH application budget, and there are no surprises there. With the cloud, it's more amorphous and requires experience and expertise to understand how much to allocate and what mechanisms to use to budget for these allocations. And although cloud is intended to facilitate reproducibility, and there are definitely a lot of several great examples of how this has been done already, but you do depend on the availability of the services and capabilities that you utilize from the cloud provider. So I want to be very open that each of those solutions, both the cloud and on-premises, has its own advantages and disadvantages. And the underlying implicit hypothesis of CRDC and Imaging Data Commons is that the computation on the cloud has benefits, can be viable, and can be attractive, and can be enabling to cancer researchers. And what we want to do with the Imaging Data Commons is to build this infrastructure, explore the capabilities of the cloud, and demonstrate best practices, how it can enable cancer research in a more reproducible, more accessible, more scalable way. So here on this slide is the official definition of what IDC is about. And as you can see, the main message here is that we want to connect the users with the data, with other types of data, in addition to imaging data, with the computational tools to facilitate those tasks of reproducibility and democratize access to data and tools for the community. Here is one kind of high-level workflow of how we envision the user will interact with IDC. IDC is the home of publicly available imaging data sets that are hosted on the cloud. So if you want to either utilize computation on the cloud, or if you just want to explore the data, you should be able to do this with the tools that we provide you in IDC. You can not just explore the data, but define the cohorts based on your needs of your application. You should be able to interact and understand the quality of both the metadata, the images, and the annotations that accompany those images, to have confidence that this data is what you actually need. And once you have done that, by the nature of data being on the cloud, you will have access to a variety of tools, cloud-based tools that are developed to work with big data to further explore and analyze it. In addition to exploratory tools, there are also computational tools that you can use, such as various types of notebooks and AI-enabled VMs, where you can do both interactive and exploratory computational analysis, but also can easily scale your analysis to hundreds and thousands of cases and VMs. And important point here also is that by using the cloud-based workflows, there is a huge opportunity to reuse components that are establishing best practice of how data should be converted from one representation to another, how to efficiently share and reference this data to make it fair, findable, accessible, interoperable, reusable, and easily share those workflows and pointers to the data with your colleagues. One of the most common questions also that we get from the community in the past months is, we already have the cancer imaging archive. What is the point in IDC? What is different? So hopefully from the previous slides, it should be clear that our focus is on supporting the users that want to utilize cloud-based computing and integrate with other components of CRDC. At the same time, we work very synergistically with TCIA, and in fact, we rely on TCIA to provide certain capabilities. In particular, we at IDC, as a FISMA-low system, can only host data collections that are completely identified, do not have PHI, and have been cleared by an authorized entity. And at this point, only Cancer Imaging Archive is that acceptable entity from which we can receive imaging data. So we definitely rely on TCIA for data identification and curation of those public collections. Also, if we don't want the IDC to become another resource that you are encouraged to use to download the data from the cloud to your laptop. You can already do this very efficiently with TCIA. And with IDC, the idea is that you define your cohorts and then you download those cohorts to the cloud-based VMs for computation. There is significant emphasis in IDC on the harmonization of data. So as I will mention later, we are using DICOM for modeling of the data, for implementing various interfaces to the data, and we proactively take the collections that are either have been shared retrospectively and work to harmonize them into the DICOM representation, or also work together with TCIA and the submitters of the data to help them share their data in such a way that it's easily harmonized and integrated with IDC by means of implementing the standard. The project was funded, so here's the status of the project. We were funded last year, in the summer last year, and as I mentioned in October, we had our first public pilot release. And this is an important point. We are following the agile development methodology. We want to hear and listen to the feedback from the users. So what you see in this release is open to modifications. And if you see something that you think should be done differently or something is missing, we are definitely open to your feedback. In spring next year, we plan to have our production release. And at this stage, definitely, we will be less flexible to implementing changes to the infrastructure as compared to now. In the public pilot release, our focus is on radiology data. In the future, in the next steps, we are extending this to support digital pathology and also other types of data. The main constraint we have is that the data sets we are including in IDC have to be relevant to cancer research and they have to be available publicly. Other than that, if it's a valuable imaging data set that is shared and has been curated, we are open to discussions of including a variety of data into our resource. As of now, we have 28 collections that are included, and this includes both the original collections and the results of analysis. Our pilot release includes the portal, which follows the familiar interface to other nodes in CRDC, curated data, both the DICOM files in storage buckets and the DICOM metadata in large BigQuery tables. We have support for visualization, documentation, all of those other components. All of this is included in our pilot release. So what I want to do next is to switch gears a little bit and show you the IDC portal and how it looks like. So this is the front page, and you can access the site without having to log in. I will, as you can see here, I have not signed in. You can see the collections that are included in IDC here. Again, as I mentioned before, all of the collections right now that are included in IDC are coming from public collections of GCIA and are subject to GCIA data usage and license requirements. The exploration portal gives you the interface to explore the data in terms of what metadata is accompanying those collections. You can either configure your search to be collection specific, or you can search across collections, and that's where the data model provided by DICOM is very helpful. We organize the various filters that we provide into 3 categories, and here we broadly categorize those filters as to those that correspond to the original data. It's the data that comes from the image acquisition equipment, derived data, which comes from either results of annotating the data or performing analysis of the data, and related data, which is for the most part clinical data that accompanies the imaging data but is not imaging data itself. So on the left you see the filters that you can select to subset the cohort. On the right you see the content of the current cohort, of course. So let's say that if I want to select images that correspond to CT, I want to select only cases that have the CT images. I can further go to derived data set. I can take a look what are the segmentations that I have that accompany CT images. For example, I want to have the segmentations. I want to have the cohort that includes cases that have CT images and nodal segmentation. And then it's a familiar interface to browse the content of the DICOM hierarchy. I select the collection and individual study. I can see which series are included here. And in the derived set, I can also see the summary of the attributes of the data for each of those related categories. So you can see related is empty here because we don't have related data for any of the cases included in the current cohort. But you can see that the derived data has different
Did we lose Andre?
Yeah, Andre, you're breaking up. You're still breaking up. The audio is breaking up. And Andre, if you can hear us, is there a chance you can increase the font size on your browser? It's a little bit small.
Yeah, I see what you mean. Yeah, hold on. Let me.
And we can hear you better now. We can hear you better now.
Okay.
Thank you.
Let me share just a single window because I think it's the reason is that I have a large screen and it's. Is this better?
Yeah.
Or not?
It looks yes, it looks okay. It was just the writing in the portal was a little bit small.
Oh, okay, all right.
Andre, perhaps you should stop your videos to get better bandwidth.
Yeah, excellent point. Thank you, Bill. Appreciate it. Okay, so I think I know the reason why my voice was breaking up is because at the moment I opened this imaging study in the viewer, we are using zero footprint OHF viewer as the basis, and every time you open the study, before you can see the image, it has to be downloaded to your computer and into the browser. So because of that, initially you will experience hiccups scrolling through the study, but once the complete study is downloaded, it should be very smooth. And as I show here, you can see both the images and also the annotations for this image in the interface. At this time, we support 2 types of annotations. It's the DICOM segmentation object, but also the radiotherapy structure set. So if I can show you another example, if I go to the original tab and select radiotherapy structure set cases, you will see here there are 2 collections right now that have this type of data. So here you see the various types of anatomic structures that have been segmented here. And for these particular collections, the annotations, actually this collection was graciously contributed by the Master Clinic and one of the definitely quite popular collections on NCI. The annotations are shared both as artistruct and segmentations. So yeah, these are the highlights of the main highlights of the portal. But also here, the idea is that once you define this cohort, you don't leave it at this point, and you don't just finish by downloading this to your computer. Let me just define another cohort, which is a bit more manageable and smaller, and I will show you how you can, once you selected the cohort, you can save it and reuse later. So here again, I start with selecting just CT images, but then I will select only the subset of the cohort that has segmentations of certain volume. So let me just adjust this a little bit. Okay, so let's say here I have the cohort of just 4 cases, as you can see here. So now if I can log in, and this is the first time I log in here. So I have the account, and there is no selection process to get an account. You apply and you register, and all you need to do is to authorize the application to use your Google ID. And here I have a little hiccup because my filter disappeared. So let me just regenerate the cohort. We are debugging issues related to handoff from of the cohort definition after you log into the system. But once I logged in, I should be able to save it. So I'll save this. So now under my account, I can go to the list of cohorts that are available here. I can go back to any of the cohorts that I defined earlier. And once the cohort is open, I can download the manifest corresponding to this cohort. And this manifest will contain all of the information that I need to pull the data to a VM, basically. So our documentation, let me actually go from here to the documentation page. In the documentation page, we have various examples how you can use the data available on IDC, and we have the notebooks, call of notebooks, one of which demonstrates how you can download the cohort to a VM. So here I can just quickly maybe go over those steps. I need to connect to the runtime. And just for those of you who are not familiar perhaps with Google Colab, it's basically a hosted instance of Jupyter Notebook. And that hosted instance is running on the VMs that are provided for free. You can use them for free by Google. And you can even allocate VMs that have quite capable GPUs, as you will see from the demonstration that Dennis will show later. So here I can upload the manifest. I can populate the path leading to the manifest. And here I need to provide the project. The project that will be built to pull the data. Even though the download of to Google VM is free, you still have to provide the information about your build project. So here is my manifest. And it's a quick notebook, so I hopefully can run it very quickly here. So I just load it as a pandas data frame. And once it's loaded, I can authenticate against Google here. And once I am authenticated, I can use the standard GSUtil that I don't need to install. As you have seen, I just clicked the button to open the Google Colab notebook. I have this notebook here, and I can download the data like this. So you can always go back to our IDC documentation, to the Colab notebook, and reproduce all of this yourself if you're interested after the presentation. Let's see. In addition to those components that allow you to work with the data and explore the data interactively, we also provide the data organized both as storage buckets as DICOM files that follow specific conventions that IDC established, and also the BigQuery meta tables that contain 99.99% of the metadata available in those DICOM files. So what I want to show you also again very quickly is how you can utilize other resources, other tools to explore the data in addition to the portal. And to show that, I will again start with the documentation. Here, what I want to demonstrate is another notebook that we have developed. And this notebook allows to explore the metadata that accompanies one of the, again, quite popular collections, the LADC IDRI collection. Again, the prerequisites here is that I need to have a project with the billing configured. And we do have video tutorials that explain how this can be done. It's quite easy. So you can see the VM is initialized. I authenticate. It's a new VM, so I need to authenticate again. Right. So now that I have the authenticated, I can use the queries, SQL style queries to query those various tables with the metadata that are publicly available and are maintained by IDC. So here, for example, I can query this table to get all of the counts for the CT images. So I can sort them and see how many CT series each case has. I can similarly query the table to explore certain attributes that is not available, for example, in the IDC portal, and explore that in this way. And also, I can configure the URL of the viewer to open the specific study or series directly from my notebook. So that's another tool that we're going to highlight, how you can quite easily explore and access the data in IDC from other tools such as your notebook. For those who are not who would like to have a more interactive way to explore the data, another tool that is available is the Google Data Studio that allows you to build custom dashboards to interact with the data backends such as BigQuery. So here again, I show a public dashboard that we prepared, and you can build something like this literally in a matter of probably less than an hour. And this dashboard is just a toy example to show how if you look at the summary of the data available in IDC at the instance level, how different it is at the series levels. And the explanation for this is, for the image series such as CT or MR, you have multiple instances for each series, and you kind of lose the information about series that include only one instance. But if you look at the series level, you can see that you have as many series that correspond to CT as you have to the series corresponding to segmentations, which is kind of a remarkable observation. So here, for example, we have the fields that are not shown in the IDC portal, where you can search by the patient weight, for example, or patient age. And this dashboard is quite responsive. It's not instant, but keep in mind that it requires quite a large data set in the back. You can, for example, do interactive search by applying regular expression to the content of series description. So if I, for example, if I search for tumor, for series that have a tumor in the tumor word in the series description attribute. Or if you want to search by specific manufacturer or modality. And here again, the dashboard is using the integration with the viewer. So now that I subset the data, I can click on the specific study from this table and open that study in the viewer. So the point is that you can very quickly, without having to install anything, you can get a quite good understanding about what data is available in the cloud, find relevant data, pull this data to a VM, and start your exploration computation on the data very efficiently. So I will go through my next few slides very quickly because I already spent more time than I thought I would spend on these ones. Just to give you some idea about key decision points and architectural decisions that we made. I mentioned before that we rely on DICOM for data harmonization, and it's a very practical decision because there is a lot of tools that implement DICOM and produce DICOM data, and we definitely need a data model and data standard to harmonize contribution from different contributors. As many of you know, DICOM can definitely be used for storing analysis results, and there are many collections in TCIA that follow this precedent. We utilize OHF Viewer, which has very few customizations to provide functionality in IDC. All of the customizations we did are publicly available. It's a zero footprint viewer. It pulls the data into your browser. It's not limited to radiology. It already can support digital pathology, and we are working to add more capabilities to support more complex imaging types. We work very closely with the OHF team. Radical Imaging, the company that maintains OHF, is one of the partners in IDC consortium. And again, all of the contributions are available to the community. Google Cloud Platform is the architectural foundation on the cloud. We rely on GCP. We try to develop our infrastructure as much as possible in a way that it can be, at least in theory, done without utilizing proprietary components. But at the moment, IDC definitely relies very closely on GCP and follows the precedent of using GCP in other components of CRDC. The portal is also open source. It's been developed by the ISB team based on their experience with the ISB CGC cloud resource. We use the components that are listed here to implement the capability. We already get questions about how to reproduce this and how to deploy similar viewers in other systems. It's definitely possible. All of the components are open source, although we don't have a set of instructions that you would be able to easily follow and deploy it at your site. So next, I want to switch gears and pass the controls to Dennis Bontempi, because I want to emphasize that we are not just developing the infrastructure. In parallel to developing infrastructure, we are developing use cases that are utilizing this infrastructure. And Dennis is one of our trailblazers in that effort. Go ahead, Dennis. Can you?
Guys?
Yes, perfect.
Nice. All right. Let me try to share my screen. You can see it?
Yes, we can see it.
All right. So thanks, Andre, and thanks everyone for joining us today. I'm Dennis. I'm a research scholar at Harvard AEM, short for Artificial Intelligence in Medicine program, led by Professor Hugo Arzt, which many of you may know. I have a background in signal processing and computer vision, but the AIM team is very heterogeneous and multidisciplinary. We are, in fact, a group of computer scientists, engineers, medical physicists, radiologists, MDs, whose goal is to help deploying AI in the clinic. And now, for AI technology to be deployed in a clinical setting, we need to prove that such methods are robust and reliable. So one of the key aspects of this is, of course, transparency. And that is why platforms like IDC can make a huge difference. The other reason why IDC is interesting from an AI research perspective is that more and more people are nowadays convinced AI is heading dangerously towards a replication crisis. It's actually hard to see a week go by without reading a piece about this topic. For instance, the one linked here is from last week MIT Technology Review. IDC can help boost reproducibility in AI research, and I'm going to show you why in a couple of minutes. So, as Andre mentioned before, the goal of IDC is to make the access to cancer imaging data easier for the research community, while at the same time potentially bolster reproducibility and transparency. To showcase how IDC could help the AI community, me and Andre designed a proof of concept use case that I'm going to tell you more about in a moment. So we started our journey investigating how the tools provided by IDC can be best used to set up an imaging analysis pipeline. We learned, and we are still learning, pros and cons of using the platform, as well as what could be the best practices for future IDC users. Ultimately, as I was mentioning before, we decided to accomplish this starting from a re-implementation of a published study using exclusively the components of IDC and Google Cloud. So the first study we decided to reproduce is PLOS Medicine Deep Learning for Lung Cancer Prognostication, in which Oshney et al. Investigated the prognostic power of deep learning extracted imaging features in a non-small cell lung cancer patients cohort. So two reasons why we choose to start from the reproduction of this study in particular. First, it is well known in the field. Second, the testing is carried out on a well-known and widely used dataset, the one that Andre was mentioned before, Lung1 dataset, from this other very famous paper by Hugo Arts. And in the case you're wondering if you want to find this collection on IDC, just navigate to the portal and select Lung, as Andre showed before. And NSLC Radiomics is going to be the first collection you will find. Back to our use case, what Oshney et al. Did in the paper was to design and develop a deep learning model on private data from different sites and test it on the NSCLC Radiomics dataset to make the results available for everyone to reproduce, as they also provided the trained model weights and a number of other useful scripts. Exploiting IDC, we can replicate the testing of the public dataset in an even more transparent way, providing the users with not only scripts and the data, but with a functioning end-to-end pipeline that runs completely on the cloud. Now, say I am an engineer, an imaging researcher, and I have trained a model that I think works great on my private data, and I want to do what Oshney et al. Did, test it on public data. So what are the differences between doing it locally on my laptop or on one of my computational nodes and do it exploiting IDC? And why should I use IDC in the first place? So let me show you why. So this is what I will personally do if I was carrying out the testing on one of the nodes at my institution or my laptop. I will look for the data set that best suits our needs on TCIA. Then I will try to figure out how to use the dataset, how the dataset is structured, download the full cohort and try to make sense of it locally. Maybe fire up my slicer, 3D slicer, probably select a batch of data I want to analyze based on some of the requisites I'm looking for. Moving on, I will make sure my environment is set up in such a way that the experiments I'm about to run are reproducible by a third party. By installing all the software, making sure that everything is compatible with every other piece of the software. And finally, I will run the analysis and look for the best way to share the results, make the process as transparent as possible. So this is what the same testing pipeline will look or looks under IDC. So the data are not downloaded, of course, are stored in IDC buckets, which are organized and thus accessible always in the same way, as Andre mentioned before. To select sub-cohorts, we can exploit BigQuery queries or create filters as Andre showed before, and the IDC OHIF viewer that runs in browser. The pre-processing, if needed, is carried out using a consistent set of tools. There is no need to set up an environment or check for compatibility, etc., as everything is already taken care of by Google Colab or the VMs that the user can choose to initiate. And sharing the results is made easier by the fact that the end-to-end pipeline is stored on the cloud and can be accessed, explored, and run by basically everyone with a Google ID and some billing information, as Andre mentioned before. So I wanted to show you real quick how a demo or a Google Cloud notebook looks like. This is the one that we developed for our use case. So as Andre showed you before, you've got a table of contents which can be used to navigate the notebook, basically a Jupyter notebook. You can evolve in such a way that the navigation is made easier. I'm not going to go through all the steps that we implement. Basically, we implemented a full end-to-end pipeline. I just wanted to show you a couple of things that you might find. Mentioned before.
Dennis?
Yeah.
Maybe if you turn off your video because you're having bandwidth problems.
Yeah. Give me a second. Okay. My screen now?
Yes.
Yep. So as Andre mentioned before, one of the great features of IDC is the OHIF viewer. In this case, when you're exploring a cohort and you want to see how data look like for some analysis, or you want to select a sub cohort, what you can do, you can generate URL for directly in the notebook, and basically for the OHIF for one patient. Or okay. It's probably lagging a bit because I was downloading all the data. So this is pretty much what Andre showed to you before. And then you can, data processing is made transparent by sharing every step with the end user. And also you can, of course, visualize the results and all the analysis run. In this case, we were just checking the RC-AUC. Of course, this is a small sub-cohort. That's why the AUC it's 1. But again, we computed a comparison with the original results in the PLOS Medicine paper. And of course, you can compute many other analyses and just share them to the end user, with the end user, without them even needing to have a Google account. This is the saved information that you're seeing here is available just by going on the GitHub and opening the Google Colab. And of course, again, everyone which is provided there, they have a valid Google ID, and with some valid billing information inside, they can access the notebook, they can run the notebook, they can modify the notebook and save it, commit to the GitHub and modify, etc. So back to the presentation. It's actually on. I also wanted to point out that everything that I showed to you in Google Colab is going to be available also in Google Cloud VMs, which are really easy to use. The idea is actually to provide the user with a piece of code that can be run locally, which will kickstart the process of creation and preparation of the VM. The end user will be able to access the virtual machine either via the Google Cloud dashboard or via more sophisticated ways, for instance, SSH tunnel. And the virtual machine will be initialized with the right environment needed for the experiment to run as intended. So you will not need to install anything. You will find everything already set up. And the user will have complete access to the virtual machine through terminal sessions that can be easily spawned. And furthermore, the development environment is equipped with a GitHub graphic user interface as well, so that sharing potentially modified versions of the code is made very easy for the end user. That is pretty much all from my side. Thank you very much.
Thank you very much, Dennis. So let me just grab the screen back, and I will just have those slides here because the presentation will be recorded. I want to mention that these are the current priorities for IDC. We have a lot of technical things to resolve on the backend side. Versioning is a big one that we are working on. We have several questions that are related to the topics that we're exploring right now. The decisions about how we will do versioning are not finalized at the moment. We have open questions related to this. As you understand, we have only a small subset at this point of collections that are available from TCIA. We have a lot of work to do to convert the digital pathology data. If there is feedback from the community, which collections, which capabilities should be prioritized in terms of the data available in IDC, we are definitely interested in your feedback. And the use case that Dennis demonstrated today is just one of the use cases we are developing. We are also working on a pathology use case, which is led by Andre Hohmeyer. We welcome your feedback in terms of how we can prioritize and better do this to inform the community about the benefits of using cloud for imaging research. And last thing I want to mention is that if you are interested to explore imaging data commons but are not ready to commit your credit card, we have free credits that we can give to you to help build your confidence and understand the capabilities and limitations of the platform. We would definitely appreciate your feedback, and we're happy to give you those free credits. So if you want to know more, here are the main points of contact: our portal URL and our forum. We definitely welcome you to join the forum and start the discussions. So thank you very much for your attention. I am very sorry that we ran over time. We didn't plan this presentation to be this long, and I'm sorry if I was speaking too fast at some point. So I hope we can have a conversation and questions from the audience.
Yes, thank you, Andre and Dennis. That was a great presentation. We have some questions in the chat. Before we go to that, I want to just ask anyone if they have a question that they want to speak to directly.
Keyvan, because we have so many people on the call and we are very pleased about this amount of interest, I had asked in the beginning to put questions in the chat. If you like, I can go ahead and read those questions and have Andre and Dennis and the other team members of the IDC team answer them.
Yeah, that would be great. I noticed
that would be great.
Some were answered, but go ahead, please.
Yes, thank you, Steve, for answering at least already 2 of those questions. So first question from Daniel Rubin. Is the search limited to DICOM headers, or can you search for associated clinical data or data types of image annotations?
Mm-hmm. Yes. So the search that you see in the IDC portal is mostly about searching the DICOM header. But because we use DICOM not just for the images, but also for annotations, this means you can also search the annotations that are in that format. The availability of clinical data in the portal is right now very limited. We only have clinical data for the TCGA collections. And the reason for this is because, as probably you know, Daniel, clinical data is very heterogeneous. And it's not possible at the moment to have a meaningful interface that would let you search clinical data across collections, because even the names of the columns for the same thing may be different. Our plan right now, and this is just at the stage of discussion, is to ingest the clinical data from TCIA as is for the individual collections and provide that data as BigQuery tables that are accompanying the other types of metadata in IDC, so you can at least search the data as is. At the same time, we hope that over time, we will be able to make progress to harmonize clinical data and make it more consistent. One of the components of CRDC is Center for Cancer Data Harmonization, CCDH, which is tasked with exactly harmonization of data across nodes. And we have already started working with CCDH on this topic. And the expectation is that we will have recommendations and procedures how this can be done efficiently for the clinical data in TCIA.
Thank you, Andre. The next question is from Zivzhanev. I hope I pronounced this correctly. If not, my apologies. And the question is, are there any plans to support non-DICOM microscopy formats?
Our current plan is to have a dual personality DICOM for the digital pathology and the whole slide microscopy. So essentially, we would have a file that would be recognized as a valid DICOM file and also at the same time as a valid OME TIFF file. I know that David Clooney is on the call right now, or he was. Maybe, David, you can comment on specifically ZAR format and whether that would be in the scope somehow. Or maybe David is not around anymore. So we would need to discuss how ZAR format could potentially be supported, or maybe it's already somehow supported in the.
Yes, sorry, Andre, I was muted in two different places. Yes, most of the whole slide images that we have to deal with at the moment are in SVS, like a Perio format. And many of the other proprietary formats are also TIFF variants. We anticipate that the dual personality DICOM TIFF file should allow those to be converted without any loss of pixel data or need for recompression of the pixel data. And the metadata will be populated in the DICOM headers, unlike the conventional proprietary formats. And to the extent that there's any additional OME TIFF XML metadata available, we'll port that into DICOM as well. For the more complex formats that are related to, for example, the HTAN data, those two are planned to be shared as OME TIFF, so the same strategy should in theory work for that to the extent that we have huge data sets, so that solutions like N5 or ZAR become available. We'll need to reconsider that and figure out how to spread those across DICOM components in the various different sub-instances in the distributed archive.
Thank you, David.
Thank you, David. Thank you, Andre. The next question is again from Daniel Rubin, and I believe Steve Piper answered it already. So the question was, how do you know how much you will be charged for cloud operations analysis you perform using IDC? And Steve basically said it depends. So Daniel,
yeah.
Is that good enough for an answer right now?
Let me maybe add a few more points to Steve's response. I think definitely the answer to this question is not simple. I think part of it will come from you developing experience using cloud. I think as you start doing some computation on the VMs, you start seeing how much it takes to store data on the cloud. You will have a better idea and will have more confidence. But also another thing to emphasize is that imaging data commons is not really the place to do the computation. That's the role of the cloud resources, that this other component of CRDC. And at least some of the cloud resources, and specifically Terra, already provides some capabilities to give you an estimate of how much a task you want to run on the cloud will cost. We do plan to work with Terra and other cloud resources to have a better understanding how reliable those estimates are for the imaging use cases. So it's an open question, but you're not the first to ask about this, and some thought has already been put into addressing this question in CRDC.
Thanks. George White wanted to know if you can, searching by clinical data, I believe you addressed this question in your first part of the answer. So I hope, George, that helps you during your question.
That was George answering the question.
Oh, that was George answering the question. Okay, thank you, Bill.
Yeah, George is on our team, yeah.
Yeah, okay. Next question is from Anna Fernandez, and Anna wants to know, is the plan that the OHIF viewer will only accept DICOM pathology, no original DICOM pathology vendor formats? And is the vision of the...
Yes.
Yeah.
Oh, sorry, go ahead.
Okay, and then the question continues, is the vision for IDC to ingest proprietary formats, convert to DICOM pathology format, and then save the original or just the DICOM version in IDC? Will IDC provide a translator to convert back to the original whole slide image format in case researchers have viewers or analytics tools that use the original formats? So multiple questions.
Yes, right. So let me see if I can answer. So yes, right now our plan is to take those proprietary formats and convert them into DICOM format. It remains to be seen how successful we will be, but we have confidence that that's the right way to handle this issue. One of the reasons we use DICOM is because we can leverage a variety of existing tools that have already been developed for working with the standard. And converters into and to and from DICOM whole slide imaging representation is one set of those tools. So there are already converters that can perform this task. As we embark on the conversion of the digital pathology data, we will test and refine those converters if applicable. And it is most definitely not our intent to lock you into dealing with a format for which there is no way to convert it into other representations. So most definitely, we plan to have instructions how you can take data in DICOM format and convert it into a format which is acceptable by your tool. We have these kind of tools for the imaging data, for annotations, and we plan to follow this for the whole slide imaging data.
More specifically,
yes, go ahead.
Yeah, I can also address that in a bit more detail. More specifically, we want to make sure that to the extent that most tools use one of a handful, or not even a handful, or one of a couple of different libraries to ingest their data. We want to make sure that those libraries are capable of ingesting the DICOM format, even though we do have to fall back to the dual personality TIFF as mentioned. So our goal is very specifically not to provide a separate store of the raw data or to provide a tool to recreate the original, in quotes, raw data from the DICOM file, but rather to make sure that the tools that would rely on the original data are capable of ingesting the DICOM data, whether it be through the DICOM path or the TIFF path. And so we have a number of library enhancement initiatives in that respect that are coming down the pipeline. There may, of course, be proprietary tools that are dependent on a proprietary format that is in some ways very peculiar and not using one of the current open source libraries, and those will not be supported by IDC.
Next question.
The next question is a comment from Jonas Almeida. He says, in Andre response to your question about pathology use case, it would be great to have granular APIs all the way to exposing the tile server. And the next question comes from Lawrence Tarbax. Will the path converters do DICOM? Will those converters be backported into OpenSlide or bio formats? So will they be available?
Yes, definitely. That would be ideal situation to have this available in the libraries that are already popular in the community. And it's interesting you ask about bioformats because we are specifically right now we are starting the collaboration with Jason Swedlow to extend the capabilities of bioformats to support to better support the DICOM whole slide imaging object. So yes, we do want to achieve that compatibility.
Okay, just another comment from Jonas. The slides are locked. Andre shared with all of us the URL where the slides can be found.
I'm sorry. Hold on.
Yeah, I think that it's okay if.
Okay, they should be viewable now. Sorry about that.
Yeah.
Yes.
Okay, and Steve also responded to Jonas again. Jonas asked, in general, how do you see the APIs in image comments, in the image data comments evolving? Do you see it evolving to the point where people would not be necessarily the environments you propose, would not use necessarily the environments you produce?
Yeah, definitely. Yeah.
Sorry for stuttering.
such as Jupyter Notebook. So definitely, I think it's already possible to use the data, explore the data using environments that we are not that developed by other people. And that's the point of showing you the notebook example and data studio example is just that these off-the-shelf tools, not designed by IDC, can be used to work with the data. So because we want to use the open data representation as much as possible, open interface as much as possible, we want to enable this.
Thank you, Andre. And this brings us to the end of the questions that we have.
Okay, and just maybe one comment related to the question from Jonas. And even though we use DICOM and we try to standardize on DICOM as much as possible, right now the interface to the data stored on IDC is not available using DICOM web interface. We provide the data that can be downloaded using either storage buckets and we provide the BigQuery BigQuery tables with the metadata. The reason we do not provide DICOM web access to the data is because Google does not allow us to have requester pays DICOM stores. So if we open DICOM store for everyone, it means anyone would be able to download the data and we would have to cover the cost. We cannot control the cost. Because of this, when we run the viewer right now, it doesn't talk directly to the DICOM web interface, but it talks to the DICOM web interface through the proxy. So it is an open question and came up with some of the users already. Can we open a DICOM web interface for accessing the data? Right now we cannot, but if there is a significant push from the community and we have a number of use cases, then we definitely should reconsider and bring this up also to our partners at Google Cloud Healthcare. So that's like a technical point, but I wanted to mention this.
Thank you. I have one more question. Okay. Can you point to the GitHub, GitLab or Hub account with the open source of the portal?
Yes, definitely. It should be in our documentation, but maybe it's not. So let me quickly. It's the Imaging Data Commons Git organization, GitHub organization.
Bill posted it already. Bill is
also. Oh, excellent.
I just did it. Oh,
thank you.
It's twice.
And Curtis comments, nice presentation, Andre, and the whole IDC team. Thank you for presenting today.
Thank you very much for attending, and I'm impressed we had so many people sticking around until the end of this talk. So.
Yes, thank you, and the team, and thanks, Uli. Just wanted to make a couple of quick announcements. Can I share my screen, Uli?
Yes, I stopped sharing.
Okay. Do you have the slide now? Okay.
Yes, we can see the slide.
Okay. So I just wanted to mention that there will be a feature presentation on IDC at the RSNA 2020 in a couple of weeks. It's on December 3rd, 5 to 6 p.m. And there will be, I think, 4 presentations included in that 1-hour slot. Presentations by Andre, of course, Pete Longabaugh, who spoke on the, he will speak on the cloud architecture support for IDC, Hugo Ertz on AI use cases, and Brad Erickson, who chairs the external advisory board for IDC, will talk about imaging applications in the cloud. And the next imaging community webinar, we will be back on the regular schedule of first Monday of the month, and it will be on December 7th. Our colleagues from the National Institute for Allergy and Infectious Disease, Drs. Rosenthal and Hurt, will present on the tuberculosis bioportal. I hope that we can join us, that you can join us for this presentation on December 7th. That's all I had. Uli, did you have other announcements?
Keiwan, if you wouldn't mind going to the next slide. Sure. I just wanted to tell everybody who may be new to the Imaging Informatics webinar, we have a Google group. Please feel free to join us there. It's NCI-imaging-community-call. And we send announcements about upcoming calls. We send announcements when recordings have been posted to this Google group. So please feel free to join us there. Today's recording will be posted on the NCI Wiki. The URL is when you scroll up in the chat, it's towards the bottom. I posted it there. It's also listed here under Imaging Community Call Wiki. And I think that's it for me. Kayvon, back to you.
Thank you. That's all. I want to thank Andre and Dennis for a great presentation, and everybody who attended and for questions that were asked. That was a great discussion. Thank you. And please follow us online at IDC and the IDC Discourse.
Thank you very much, Uli and Kayvon, for having us. Appreciate it.
Thanks, Andre. Thanks. Thank you very much, guys.
Thank you, IDC
Thanks,
team.
everyone. Bye.
Okay.
Bye.
Bye, guys.